Welcome to Lesson 2, Part 3, Video 2 for Unit 6, Solutions 1 in Chemistry 2. So in this video we're going to look at stoichiometry. So now we're going to take stoichiometry, which we've been talking about all year. We've been using it in different forms. You learned it in Chem 1. Now we're going to put solutions to this. So we're going to be using molarity as a conversion factor, and that's probably the biggest thing. So this is really nothing new other than we're using molarity as a conversion factor. So if we're given whatever molarity, that is moles over 1 liter of solution. Here is our conversion factor. This is our molarity. So we put the molarity that we're given over 1 liter, and we use it to go between moles of something and liters of solution. So in order for us to have this, we have to have a balanced chemical equation. And we are given one here. This is balanced. We have sulfuric acid and sodium carbonate, which gives us sodium sulfate, carbon dioxide, and water. So calculate the volume of 0.324 molar H2SO4 needed to completely react with 2.792 grams of sodium carbonate. So this is a gram to volume problem. We could easily reverse this also and do a volume to gram problem. So, as always in stoichiometry, we are going to start this one with the grams of the given. We're not going to start with molarity because that's our conversion factor. So 2.792 grams of Na2CO3. Now, since we're given a molarity and we know that we're in moles, what do we always do with grams? We change them into moles. So we need to calculate the formula mass for Na2CO3. Remember, 2 decimal places for everything. Round them to 2 decimal places. So when we do this, you should get 105.99 grams of sodium carbonate are in 1 mole of sodium carbonate. Now we do our mole-to-mole ratio. So we're going from sodium carbonate, and we want to know about sulfuric acid. So it's a 1-to-1 mole ratio. So now we look, these all cross off. If we stopped here, we'd be in moles, but we want to know volume. And we're given a molarity. So this is our new step. Well, 0.324 molar H2SO4 means that we have 0.324 moles of H2SO4 in 1 liter of solution. So moles are here, so I'm going to put my 0.324 moles of H2SO4 on the bottom so it cancels out, and 1 liter of solution on top. Now I'm just going to do the math. So 2.792 divided by 105.99, hit equals. Our mole ratio is 1-to-1, so we don't have to worry about that. So then we just have to divide that answer by 0.324, round it to 3 significant figures, and we get 0.0813 liters of H2SO4 solution. Now it asks for milliliters. You'd have to multiply that by 1,000. So we did 81.3. That is our answer. Our second example here says find the volume of 0.505 molar NaOH needed to completely react with 45.0 milliliters of 0.250 molar H3PO4. So this is a volume to volume reaction. And because molarity is in moles per liter, and we're given milliliters, we have to convert this to liters. So remember, divide by 1,000 gives us 0.0450 liters. We're going to start with our volume here. So we have 0.0450 liters of H3PO4. We're going to use a molarity twice. A volume to volume, we do not have to worry about formula mass because we are already in moles with molarity. This is already balanced. You can see that we have coefficients in here. So we know that we have 0.250 molar phosphoric acid, which means that we have 0.250 moles per 1 liter. So we want to get rid of liters, so that goes on the bottom. And a 0.250 moles of phosphoric acid goes on top. That allows us to cross off our liters of phosphoric acid. Now we have to go between phosphoric acid and NaOH, so we use the coefficients. Well, there's a 1 in front of H3PO4, so 1 mole of H3PO4 reacts with 3 moles of NaOH, and we set it up so our units cross off. Now, we don't want our answer to be in moles. We want it to be in volume. In this case, it's going to be liters. It doesn't ask for anything, so we can leave it in liters. If it asks for milliliters, we get liters and change them. So 0.505 molar NaOH is 0.505 moles of NaOH over 1 liter. So 0.505 moles of NaOH goes on the bottom, and 1 liter of NaOH goes on top. 0.0450 times 0.25 hit equals, times 3 hit equals, divided by 0.505. 3 significant figures gives us 0.0668 liters of NaOH. That is our final answer. It'd be 66.8 milliliters.